Hello guys, in this video we are going to solve a new problem. So in this problem we are given a sorted array and a target value, and we want to return index. If the target is found in the sorted array, then we want to basically return the index of that element in the sorted array. But if say target is not found in the sorted array, then we want to return the index where the target should be placed in the sorted array. And now if we look at example, this problem might be easier to solve or understand basically. So if nums is this array and target is 5, in this case 5 exists in the nums array and the index for 5 is 2, and therefore that's the output. Similarly, in the example number 2, target is 2 and 2 does not exist in this sorted array. But we know that 2 should be placed between 1 and 3. Therefore, the index of 2 would be 1, and that's where we want to place the target, and therefore the output is 1. So that's the problem. One more thing about the problem is that we are expected to solve this problem with the time complexity of O of log n. If I were to solve this exact problem with a code that has complexity of O of n, then the code is pretty simple. In fact, if I just copy and paste the solution, you can see that all I'm doing is iterating through this list. I'm also keeping track of the index using I, and I only have one condition. If the element value is greater than or equal to target, I want to return the index at that position. Because this is a sorted array, the elements will come in an increasing order. As you can see in the example 1 is less than 5, so this condition is not satisfied. 3 is less than 5, so this condition is not satisfied, but 5 is equal to 5, and at that position I want to return the index. Similarly, if the in example number 2, 3 is greater than 2, so we want to return that index position at that position. Similarly, sometimes the target is much greater than any element in the list. In that case, this if condition is never triggered. In such situation, we are simply returning the length of nums. Now, to solve this problem in O of log n, I was thinking I have to create a binary search tree. Now, because this problem, if you go to the topics, you can see this problem is has a topic of array and binary search. So I thought I have to create a binary search tree and then do an in order traversal to find that index. But if I do in order traversal, then the complexity of the problem becomes more than O of n actually. And to actually solve the problem, I've actually written the solution in this Sublime again. You can see that to solve this problem, I am simply using the concept of binary search tree. I have first initialized left and right. Left is the position 0 and right is at position length of nums minus 1. And I'm using a loop. That while left is less than or equal to right, this loop runs, and in any case left is greater than right, then the loop, it terminates, just like in the binary search tree construction. Another thing is that we also compute the mid value. This is basically a floor division of the sum of left and right. Basically what we're trying to do is split the sorted array into left half and the right half, just like in the binary search tree. And using that, first of all, I'm comparing the element which is in the mid position with the target. If it is equal, then basically mid is our answer. Mid is the position we are looking for. But that if the target is bigger than the element at the mid position, then we know that the solution or the position we are looking for is on the right side of our binary search tree, or in this case a list. So what we are doing is that shifting the left to the mid plus 1 position. Basically we are removing the left half of the our tree, or basically list. Similarly, if target is less than the mid position, then we know that our solution is on the left side, and for that I'm shifting the right pointer to mid -1 position, and this continues until left is bigger than right, and at the end we are also returning left. So you can see if I run this should work just fine. So in this case, target is 8, which should be between 6 and 9, and therefore 0, 1, 2, 3, 4. 4 is the answer. We want to make sure the 8 is between 6 and 9. So that's the solution. So if I run this solution, or basically use this solution in our Leetcode, that should be just fine. There you go, that's the answer.